I put in a Dilbert cartoon. I'm going to take you through very quickly the process flows and the procedures, and these are the kind of the what and how of the data quality management framework. So in this case, this is kind of the meat of the process, if you will, the bit in the middle, the bit where you kind of visualize and write down what a process is about or understand what a process is about. So the process themselves describes the what of data effectively, and we have the next few slides will show you a nice little neat visualization we use that show the movement of data from when it's created or when it's gathered or whatever format you want to call it, to where it's published or where it ends up or where it starts over again. So to take you through a very simple process flow, and this is one that we do for our water sampling on board our vessels. I think this is fairly easy to start. You start a little green box here in the bottom left-hand corner. You go on the ship, you do some water sample, you do some analysis either on the ship or back in the lab, you do some quality data integrity checks, you upload it to wherever it's going, and you store it in a database or somewhere else for later distribution, and then that's the end of the process. I think that's fairly straightforward, and for a lot of people, that's the level that they want a process flow on it. They want to see their job, what they do on a very high level, high concept kind of way. But you're also able to actually delve in more into the more complexity in a process that can actually help people, one, understand what they're doing, and two, actually share what they're doing with other people, and so other people can be able to follow it. So this is a more multifaceted process flow. Another example, this is how we the acoustic sensor calibration, so like the likes of our fish tags, how we calibrate those sensors before they're deployed out at sea. So again, we have a little green circle to indicate the start point, and then we have it's actually you immediately have two different options to start. Either you are reusing a sensor or you are starting from scratch and a new sensor taken from the manufacturer. And then you actually have choices in here as well once you actually go through that bit of what type of instrument is it, and then depending on the instrument you have different things come out of it. Whether it's a sound trap, then you have a sampling type, or whether it's a C-pod, then you immediately create data, or if it's an acoustic release, you have a release mechanism which actually releases the actual device back to the surface. These are kind of interesting multifaceted ways of doing things. Then again, you can go even to more detail, and I won't really go through this one as much, but this is basically an inventory system which can be used kind of to track what data you have in terms of inventory, and you can go through a whole litany of different channels and different lanes, different decision points, and what you do with it. It can just show you the adaptability of a process flow to be a very complex process into a fairly straightforward flow that you can, if you got into it, could follow. And then you have the kind of people who go way over the top. So Rob in the previous presentation showed you an excerpt from the data management plan for the same process. This is the ROMS hydrodynamic model. So this is one of the Northeast Atlantic model that the guys in our modeling teams do. And this is highly complex numerical analysis to predict temperature and the likes of that. And they really went after the process flow side of things and adopted it. And I think they are a champion of process flows, if you will. And they not only mapped out their process in this nice visual representation, but they actually made it part of their process, so that every one of these, links you see here, like the docs or the MATLAB files, are all part of the process, and they basically click through these and do whatever is in those files as they're going through the process. So they have a running audit of everything they're doing. And that's in an extreme level very useful for them. I'm not saying everyone could adopt a type of model like this so that you integrate your whole process inside a visualization, but if you can, I think it's very handy, and I think it makes something that, generally speaking, you need a PhD to understand a bit more understandable to lay people, and I think it's good for communication both upwards and downwards in an organization. But at the same time, if this is useful for you for pinning up on the wall and understanding what you're doing, I think it's acceptable, and it does help you both identify and understand your processes and see if there's any process improvements to be made in them, and if there's any useless bits to do in it. The last bit then I'll show you before handing over is procedures, and this is a case of the how, and it's the detailed steps, the checks, documentation, how the process is conducted, how it is reproducible and repeatable. So examples of such things, basically a standard operating procedure, a user guide, those type of things are generally what we'd expect for procedures. And you have them yourselves. Everyone has documentation saying how to do a particular job, how to send a certain email, how to talk to a certain person. All of these things, they tie into procedures. But also we have this other thing that I'm going to go through very quickly, which we call notebooks, Jupyter notebooks in this sense, where you can actually tie together a document in a web browser document that you can send to anyone can read it, and also have in actual processing and actual code and other useful basically methods in there. And it's a Jupyter notebook is a documentation. The web browser, like I said, it can run code, so it can run Python, Julian, or as standard, but it can also run basically anything. A lot of things have been made running in Jupyter notebook. So if you have any processing or any quality checks that you want to run, you could probably run them through Jupyter notebooks and share them around without worrying about anything. It can also provide visualizations, so you can have little, like in this little image here, this little graph can be produced based on loading it from a data file, so you can see where your data is. And if you want to run stats after statistical analysis or spatial analysis, all of those tools exist within Jupyter notebooks, which is very handy. It's open source, the Jupyter one is, but also Esri have a flavor of it. So if anyone has any Esri licenses or anything like that, they do have their own version of notebooks that you plug into for doing spatial analysis and kind of producing these type of things very quickly. Microsoft have their own Azure version of notebooks for hosting. Google have their own effectively free Colab version of it as well, which is very handy. And it depends on what you want to use, but all of them are essentially the same thing. They're all quality. Can be version control for quality assurance and can be kept around for audit purposes. If you ever have to go back and reproduce, like Adam was saying at the beginning of this, talking about the FAIR principles, if you ever have to go back and you're worried about reproducing data, you could have one of these notebooks aside and just leave it there, and you can say, okay, I'm confident I can reproduce this data without too much effort, and I'm not worried about someone leaving the business or someone retiring or something else happening to somebody, because you have this notebook left behind that they filled in, and you can stand over it. I want to check on time, but I have a little video which is just give an example of this is what Jupyter Notebook looks like when they're running. So it's just in your web browser, it's a local host thing. You just start up a notebook. This one is for updating. It's for running QC data on biological data, I think, and in water samples, and it runs through a whole QC routine that's been written with the scientist, and you have a bit of documentation around it that it kind of explain what every bit is doing. And you can just, like what I'm going to do here is just restart and run all, which just runs the whole thing. So you can run it one by one, you can follow the whole thing through, or if you want, you can run it like this in a couple of seconds and it'll upload the data, and you're basically you're done then, which is, I think, is much better than a lot of current systems, especially if you were following this in a Word document and you were hopping back and forth between a Word document and what you were doing. I think this is it's a much cleaner way of doing that, and it's less likely to cause mistakes. I'm conscious of the time now, so I'll leave it there, but